Hey, Mr. P here. This video is all about the formation of fingerprints. So how are fingerprints formed? What are the big patterns that form as the result of kind of some genetic and environmental influences? In the last video, if you recall, we talked about the history of fingerprinting. So from the 1600s on, the introduction of research and how that resulted in ultimately the database APHIS. So if you haven't seen that one, make sure you go back and look at it. But this one is all about formation of fingerprints. So how the fingerprints physically form. Let's go. So what are fingerprints, first of all? Fingerprints are small ridge patterns that are found on pretty much all areas of the hand, not just the fingertips. Okay, you can actually see ridge pattern detail on the palms. You can see ridge pattern detail all the way up and down the digits or the phalanges. But obviously from a forensic standpoint, and the part of the hand that has become infamous with forensic science is obviously the fingertip and the fingerprints that result from the ridge patterns on those fingertips. So fingers, toes, feet, and palms are all covered in these small ridge patterns, which are raised portions of the skin that are all connected units called dermal or friction ridges. And the purpose of these ridges, when you look at them really closely, like in this image, is to increase friction. That's why they're called friction ridges, so that when we grip things in our environment, we actually have an increased grip strength and an increased grip friction that allows us to do things and navigate our environment. So from a physiological standpoint or an evolutionary standpoint, they actually give us a benefit. They increase our fitness within our environment. Okay, they help us with our grip on objects that we touch. However, on the other side of that, when we touch things or press them against smooth objects most of the time, we leave impressions called these fingerprints, okay? And that's because in addition to having the friction ridges on our skin, they are actually also associated with sweat glands. So you can see these little dimples. Those are all pores. Those would be connected to sweat glands in the internal layers of our skin that are actually going to secrete sweat, which not only helps to lubricate the hands and keep the skin moist, it also aids in the friction because it increases a moisture, and moist hands are actually easier to, or more friction, create a bigger friction coefficient than dry hands. Okay? But because the sweat is secreting from these sweat glands and sitting on the surface of our skin in order to increase friction, which allows us to have a higher fitness in our environment, the oil sitting on these ridge patterns actually is what is transferred to a smooth surface like glass, which leaves the tall tale impression called a fingerprint. Okay, these secretions are a mixture of mainly water, oils, and salts, but they also can trap dirt, which can make the fingerprints more visible on certain objects and certain color backgrounds. Okay, so how do these fingerprint ridges form? Fingerprints actually begin to form at the beginning of the 10th week of gestation. So we are talking 10th week of fetal development, obviously way before the birth of the baby. Your fingertips are already forming these fingerprint patterns, and they form as the result of the interactions of the amniotic fluid that the fetus is developing in. Okay, similar prints are formed in many areas of the body, such as the palms of the hands, soles of the feet, and actually the lips. And you'll learn later on in our forensic science class and in the labs that we do that you actually can get ridge detail from your lips, especially if there is something placed on the lip like chapstick, lipstick, something that's easily transferred from the lips to a smooth surface or paper. You can actually see ridge detail on the lips as well. So it's interesting to note that identical twins have the same DNA, however, do not possess the same fingerprint pattern because they are actually formed, again, away from, kind of independent from the DNA. I put this in the slide. It's important to note, and I'm going to star this. If fingerprint patterns were determined by a person's DNA, you would expect identical twins to possess the same fingerprint patterns because identical twins possess the same DNA. However, because identical twins don't possess the same DNA, or because they don't possess the same fingerprints, but possess the same DNA, fingerprints must be produced as a result of environmental influences, not DNA influences. So, because the fetal development takes place submerged in a fluid called amniotic fluid, these fingerprint ridge patterns result as the result of the interaction of that growing skin tissue alongside the amniotic fluid that the tissue is forming in. So, the development of fingerprints happens in the basal layer of skin where new skin cells are produced. You'll notice that there is a different kind of layer of skin as you progress from interiorly to exteriorly. Obviously, this is the outside of a person's skin. You can see hairs protruding, obviously, to our environment. You have an epidermis layer. You have a dermis layer, which is kind of the middle layer. And then you have this subcutaneous layer, which is the internal layer, all of which is skin. And so the basal layer of skin is inside. It's actually kind of like right in through here. It's inside of the skin layer that you physically see. So I know that fingerprints are actually protruding to the exterior of the skin, and you actually can see them on the outside of the skin, but they are not actually forming there. They're forming in this basal layer and then just manifest themselves on the exterior of the skin as a result of the formation of these ridge patterns underneath the top epidermis layer, if that makes sense. Okay? As the basal layer grows, unique ridge patterns form, influenced by the environment surrounding the fetus. And like I said, the new skin cells are forming here, and so that's where all of the cell elongation takes place. And as the cells elongate, they're pushing into each other, and it forms these ridge patterns. Okay? And because the ridge patterns kind of originate here, they are, as we'll learn in later videos, not easily influenced externally, meaning you can't really do much to alter or disguise your fingerprints. And like I said, it's foreshadowing, more to come on that. But fingerprints actually originate here. They just manifest themselves as ridge patterns on top as the result of the epidermis sitting directly on this dermal layer. Okay. The pattern cannot be altered or destroyed permanently by skin injuries because the outer layer of epidermis protects it. Again, when you burn your finger, for instance, the skin cells are just going to grow back, but you're not actually burning the underneath layer. Now, obviously, if you get third-degree burns and you burn a large portion of the skin tissue off, then you may alter the fingerprints a little bit. But for the most part, the standard injuries that happen at the skin level are not going to interact the underneath side of your skin nearly enough to alter or mutate or permanently destroy the fingerprint pattern. Okay, so what are some characteristics of fingerprints? You'll notice there are 3 prints here. Obviously, those prints are different. They both, or all 3, have different ridge patterns. And so there are 3 distinct classes of fingerprints, one being the whorl. Whorls look like a bullseye, and they are in a rough proportion of the population, around 30%. Okay? Whorls constitute roughly 30% of the population and look like a bullseye. The next one is arches. It obviously looks like an arch. Change the color. Can't really see the purple. It looks like an arch. Okay? They kind of come up and down, and that is going to make roughly 5% of the population. This is the most rare, or the rarest fingerprint pattern. Arches have ridges that enter from one side of the finger and leave from the other side with a rise in the center. Again, you guys know what an arch looks like. Arch looks like that. These are fingerprint patterns that start low on the left. They exit low on the right, but they go up in the middle. The last one being loops. loops make up 65% of the population. This is by far the most common of all of the fingerprint patterns on the planet. They enter and exit from the same direction, meaning they're going to enter from the left in this case and exit on the left in this case. Now, loops don't always enter and exit on the left or your left as a person. Sometimes loops are going to enter and exit to your right. Again, we're going to dive into the intricacies of each of these in a minute, but from a generalized fingerprint pattern, these are the three distinct classes of fingerprints. There are some differences that are going to occur within these three classes of fingerprints, and so we will further diversify these classes in a minute, but I wanted you to see all three of them together: whorls, arches, and loops. Again, we will talk about this in a minute, but when we kind of focus on loops, there is an ulnar loop and a radial loop depending on the direction of the opening, and that depends on whether or not the opening is pointing toward the radius or towards the ulna, which is towards the thumb or towards the pinky on an individual. Okay. The core of a fingerprint is the center of the loop, so this would be the core on this particular fingerprint. And radial loops are going to open towards the thumb because the thumb side of your lower arm bone is the radius bone, and the ulnar loop is going to open towards the little finger or your pinky finger, which is towards the ulna bone. So if you have a loop fingerprint that opens to the left on your right hand, it's going to be towards the thumb because it's on your right hand opening to the left. That will be a radial loop. The same exact fingerprint opening to the left on your left hand will be an ulnar loop because it's opening to the little finger on your left hand. So when you are kind of identifying and analyzing a fingerprint that is a loop, you not only need to identify minutia patterns within the fingerprint itself, you also technically need to identify whether or not it's from the right hand or left hand so that you can diversify whether or not it's a radial loop or an ulnar loop, because that can make a difference on your analysis. Okay, so let's focus on loops for a minute. When we look at this person's hand, you can see that this fingerprint, if it was on this fingertip, is a loop. It's opening to the left, which is towards this person's thumb. If it was on this hand and opening in this way, it would be a radial loop because it is opening towards the thumb, which is the radius bone of their lower arm bone. If this was a fingerprint that opened to the right on this hand, it would be opening towards the ulnar bone or the ulna bone, which would be opening towards the little pinky finger, and so it would be a completely different pattern on the same hand of an individual. Okay? Again, loops make up 65% of the population. You have to know which hand this loop fingerprint pattern is on in order to make a kind of a good diagnosis or a good analysis. But there are radial loops and ulnar loops. They look identically in the way that they open. It just depends on, based on how they open and which hand they are, to designate which one, the radial loop or the ulnar loop, you're talking about. Whorls, again, look like bullseyes. Okay, there are roughly 30% of the population exhibiting whorls as their fingertip or fingerprint patterns. There are 4 different types of whorls, and so if we diversify, you can see that the majority of the whorls out there in the world are plain whorls, which are your typical kind of easily identifiable bullseye. That's roughly 24% of the population. Again, all of the whorls combined are going to be roughly 30%, so 24 out of 30% are going to exhibit the plain whorls. There is one or more ridges that make a complete spiral, meaning there will be one or more ridges that make a complete circle in this particular whorl pattern. And there are 2 deltas, and we haven't really talked about what deltas are yet, but deltas are these kind of triangular patterns which can be seen in a lot of different fingerprint patterns. Plain whorls typically have 2 deltas. One of them is here, one is here, and in a plain whorl, if you connect a line or draw a line between the 2 deltas here, there is at least one concentric circle that should cross the line. Okay, there is a concentric circle that should cross through that line between the deltas. If they do, you can determine this to be a plane whorl. A central pocket whorl is a very rare whorl, but that is roughly 2% of the population will have this particular whorl pattern. There is one or more ridges that make a complete circle again, and there are two deltas. One of them is here, triangular pattern. There is also a triangular pattern here, and again, if you draw a circle or draw a line between them, in this pattern there is a concentric circle that should cross the two lines. Okay. 4% of the population typically have a double loop whorl. You can see that there are basically two different directions of our bullseyes. Has two separate loop formations and two deltas. This is kind of a loop. This is a loop. They open opposite ways. There are two deltas. One delta is here. The other delta is here. There is nothing really to do with drawing a line between them. One of the loops is up here, one of the loops here. This is kind of like that yin-yang kind of picture or shape. Accidental whorl is by far the most rare of all of the whorls and probably all of the fingerprints in general. This is 0.1% of the population, and when you look at it, it has two or more deltas and has a combination of two or more other patterns other than the plane arch. Okay, so you'll see like bits of, so there's a delta, there's a delta, there's a delta, and you'll see kind of some loop-like format or loop-like fingerprints. You also see some arch fingerprints, and so it's kind of a combination of all of them. We call it an accidental whorl, and definitely makes up a very small percentage of the population. Looking at arches, roughly 5% of the population will experience the arch. Remember, the arch is the just the up and down. It enters and exits on the enters the left, exits the right, goes up in the middle, and there's a plane arch, which 4% of the population will experience, and then there is a tinted arch, which is roughly 1% of the population. The plane arch has ridges entering one side, rising in the middle, and exiting the other side. Does not have a delta. You'll notice there is not a triangular fingerprint pattern or a triangular pattern like there is in this particular fingerprint. But you still have it entering one side, exiting the other side. It still rises in the middle, but there is no delta. We call that a plane arch. And then tinted arch is a much more steep arch. You still have entering the left, exiting the right, but there is a delta, and there's what looks like kind of a line that extends up the fingerprint that makes the arch a lot steeper. Okay, sharp rise in the center of the arch and has a delta, which is an important characteristic of this particular arch. Okay, that's all I got for today. Bring your questions to class. See ya.